Alright, you're welcome to this lesson, and in this video you have been asked to check the continuity of this function, this piecewise function, x plus 1 for x less than 1, and x squared plus 2 for x above or equal to 1. Now we have been asked to check its continuity at x equals 1. So how do we do this? What we know is that for you to have a continuous function, the first thing is that f of a must be defined. We said so in our last video that f of a must be defined. Now let us check the three conditions. The first one says this. The second one says that the limit as x approaches a from the left of this function must be equal to the limit as x approaches a from the right of this function. They must be equal. So the limit as x approaches a from the left of this function must be equal to the limit as x approaches a from the right of this function. That's the second condition. And the third condition says that that f of a must be equal to this limit. The limit as x approaches a entirely must be equal. Now if these three conditions are met, then we can say this entire function is continuous at x equals 1. Now in the last lesson we discussed what we call removable discontinuity. When a discontinuity is removable, when do we say it is? It is when the limit exists but the function is not defined at a. If a function is discontinuous and removable when the limit exists, the limit of the function exists, but f of a is not defined, but this limit exists. Now in this question I will be explaining what we call the jump discontinuity, when a discontinuity is jumping. Yes, so when do we say a function is at a jump discontinuity? Now let us first of all evaluate this function and see if it is discontinuous. Let's just check. The first one says that f of a must be defined. F of a must be defined. So f of a is equal to f of 1, because we know that our a is 1, and which is equal, let's pick any of the equations and put it, x plus 1 is equal to 1 plus 1, which is equal to 2. So f of a is equal to 2. Now let us check the limit of this function as they approach the right and the left. So the limit as x approaches a from the left. Now from the left, which of these equations are we supposed to pick? All you have to do is check your inequality sign. Which of these signs is facing the left? This one is facing the left and it's to the left of 1, so we use this function. So we have x plus 1 is equal to 1 plus 1, which is equal to 2. And the next one says that limit as x approaches a from the right of the second one, and obviously x squared plus 2 is equal to 1 squared plus 2, which gives us 3. Now you can see that f of a is defined at x equals 1, but the limit of these functions are not the same. To the left of a we got 2, to the right of a we got 3. So at this case we can say the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x does not equal, but f of a is defined. Now this kind of discontinuity is what we call the jump discontinuity, and trust me, it cannot be fixed unless what we did in the last video. Yes, when a function is discontinuous and removable, you can fix that one, but when it has a jump discontinuity, it can't be fixed. So thank you, and see you in the next lesson.